Hi everyone, welcome back to our channel. Today we are going to understand what is meant by the phase difference of an alternating quantity. So phase difference means this nothing but difference between the phases of an two alternating quantities. Okay, so the difference of angle. Okay, so the difference between the phases of an alternating quantity is called as phase difference. For example, let us try to do in three cases. First one, we are considering resistive load. Okay, so in a resistive load, what happened? The instantaneous value of induced EMF E is equal to E maximum sine of omega t plus or minus 0 degrees. This is the instantaneous value of voltage, and similarly the instantaneous means these are the values which are varying with respect to time. Instantaneous value of current I is equal to I maximum sine of omega t plus or minus 0 degrees. So here you can see here the difference in phase. What is the phase difference means? The difference between the phases. 0 minus 0 is how much? 0. So I can say here the phase difference in resistive load. Okay, the phase difference in resistive load is how much? 0. Okay, so how to draw this waveform? Let's try to see vectorially. Okay, let's try to draw the phasor diagram. If you draw the phasor diagram for resistive load, the diagram will be like this. Okay, so in order to understand, I will use the two colors. It will make you an simple clear. So this is an instantaneous quantity which is varying with respect to time. I'm drawing the voltage as well as I'm drawing the current. So this is the waveform. Okay, so this is having a complete cycle of 2 pi, and this is of pi, and this is of pi by 2, and this is of 2 pi by, I mean 2 pi by 3. Okay, so this 3 pi by 2. So here you will be having this is of 180 degrees, and this is of 360 degrees, and this is of 90 degrees, and this is of 270 degrees. Okay, so like this we can write down. Okay, so now we have drawn the voltage. So how to write down for the current? Okay, so now current also will be of same, but phase angle is 0. Okay, so you can see here both this black color is nothing but current, and this red color one is nothing but voltage. You can see here, since they are in phase, I can say now voltage and current are in phase with each other. Is the first point you have to observe. Second point is the phase difference is equal to 0 degrees for this diagram. Okay, this is how to understand. We can represent in one more style also. So this is called graphical method. So in this graphical method, we will use voltage as an reference, V at an angle 0, and here you can see here, and current is also at an angle 0. So if you write down this in this format, I can write down this as, so EM by 2 is nothing but RMS at an angle 0. So this I can write it as IM by root 2 at an angle 0. So this EM by 2 is nothing but RMS quantity R at an angle 0. Fine. Okay. So this is called RMS quantity. So how to write down RMS is maximum value by root 2 value will give the RMS. Here also maximum by root 2. So this is nothing but RMS quantity when you are expressing in the case of an phasor, in the case of an R comma theta. Okay. So here you can see voltage and current are in phase, and phase difference is 0. Second case, let's try to consider where I am going to consider inductive load is there. So when you have inductive load, the instantaneous value of induced EMF E is equal to E maximum into sine of omega t, and it doesn't has any angle 0 degrees. Okay, already I told here this is also in degrees, this is also degrees. Why? Because where omega is nothing but radian by second into t, I can write it as second. Second will cancel. So this is in radian and this is in degrees. So both are of angular value. No issue. That's why you can do like this. And I can write down the instantaneous value of current is nothing but I maximum into sine omega t. And here let us try to consider this as a minus 5. So I am going to write down this in a simple format: 10 sine omega t minus 30 degrees. If you write down in angular form, so this is maximum, but I want to write down in RMS: 10 divided by root 2 into 5. This 5 I can write down it as minus 30 degrees. Now let's try to draw the waveform to understand all these things. Okay. So similarly, x-axis we have time, y-axis we have voltage or current. Now when you are drawing this waveform, so this is the waveform we have, and this is for 180 degrees, and this is nothing but for 360 degrees. This is for 90 degrees, and this is for 270 degrees. So when you write down this waveform, so here already this is the voltage waveform. Here you can see here I want to draw the current with an angle of how much? Minus 30. So minus 30 means at t is equal to 0, it should have an negative instant. At t equal to instant 0, it should have a negative magnitude. So therefore, the waveform I'm going to draw with black color where you can understand better. So this waveform is like this, and it travels like this, and it has an magnitude, and it will be traveled, and somewhere else it has already started. Okay, so now here you can see here the angle provided here is how much? Phi is equal to minus 30 degrees. Okay, therefore I can say here uh, at t equal to 0 it is having an negative instant and with an angle of how much? Minus 30. So I can see here when you write down this waveform, current lags voltage leads by how much degree? 30 degree. Very important. Okay, current, I mean already voltage is there. Okay, so first one is nothing but this one, and second one what is starting is current. Therefore current is lagging with an angle of minus 30. Current lags the voltage by 30 degrees. So if you want to drawing in uh, the graphical method, you can see here how we are drawing. This is V at an angle 0. Okay, so this I am writing it as Em by root 2 at an angle 0. But current when you draw here, this is 10 at an angle of minus 30. Okay, so this when you travel in counter clockwise direction, the reference we are going to take it as a plus 5. When you travel in clockwise direction, we have to take it as a minus 5. So what is the magnitude here? 10 by root 2. Okay, so draw that magnitude. So it is having an 10 by root 2 and with an angle of how much? Minus 30. So whenever it is traveling this direction, this is minus 30 degrees. Okay, so then this magnitude is 10 by root 2 at an angle of minus 30 degrees. Okay, so this is the current and this is the voltage. Okay, so these are the instantaneous voltage and currents. Sorry, we are drawing directly the phasor diagram like this. So we are having V at an angle 0 and I at an angle of minus 30. So here you can see here, this I am taking as an reference. Here you can clearly understand current lags voltage by how much degrees? 30 degrees. Therefore, this kind of behavior are generally exhibited by inductors. So here the phase difference. So we are writing all these things. Phase difference. What is the phase difference here? So phase difference is equal to uh, here it is how much? 0. 0 degrees minus of minus 30 degrees. Minus into minus is how much? Plus, which is nothing but Here the phase difference is how much? 30 degrees in the case of this problem. Okay, that's how to understand for an inductor. Now let's try to draw for an capacitor. The case of a capacitor, I'm writing E is equal to Em sine omega t plus or minus 0 degrees. When you write down in polar form, this is Em by root 2 at an angle of 0 degrees. So similarly, if you write down the current I is equal to Im sine omega t plus 30 degrees. So when you expand it in clearly, I can write down, I'm taking an example, 10 sine omega t plus or minus 30 degrees. So when you write down in polar form, 10 divided by root 2 at an angle of 30 degrees. So this quantity is nothing but RMS quantity. So root means square. So RMS means generally RMS is equal to maximum value by root 2 if you perform. This is 70% of the value. This maximum is nothing but 100% of the value. 100 by root 2 will get the RMS. When you're writing in polar form, you have to express only in at an RMS only. Okay, so now let's try to draw the same diagram what we have been obtained here. So initially we'll try to draw the voltage waveform for better clarity. Okay, so this is instantaneous quantity, time versus voltage and current. Okay, when you draw this waveform, this is the waveform so of voltage. V is equal to Im sine omega t. And now we need to draw the current. So current is of how much angle? So 10 at an angle minus plus 30. Okay. So how to draw this is, so this at t equal to 0, it should have positive instant. It should have positive instant. Where the positive is at upper. Okay. So now I'm going to divide this into, this is 2 pi, and this is 90 degrees, and this is 270. Okay, so now I'm drawing the waveform of current. So waveform of current, this should have an at t equal to 0, it should have an positive instant. At t equal to 0, it should have an positive instant. So here you can see here at t equal to 0, you are having a positive instant. Okay, so therefore this is the waveform of current. So if you want to draw it in one more fashion, so here I'm taking voltage at an angle 0, which is nothing but the reference. Okay, so here 10 by 2 root 30. Okay, so here I'm going to get the current, which is 10 by root 2, and whenever it is traveling in counterclockwise direction, the angle is how much? Plus 30. So when you write down in polar form, this is 10 by root 2 at an angle of 30 degrees. Here you can see here voltage is there, and this is nothing but current. Current, I can say here, current leads voltage by an angle of 30 degrees. Here also you can see here, so the waveform is already started somewhere else. The angle where it travels is plus phi. Here also I can say here. So this is the reference. Already the waveform started. Therefore I can call it as current leads voltage lags by how much? 30 degrees. So this is the waveform how we can draw, and this is valid in the case of an capacitor. So if you understand this phase difference, when you find the phase difference here, okay. So when you draw the phase difference, this is how much? 0 degrees minus, what is the angle? 30. The phase difference is how much? Minus 30 now. Okay, so therefore I can say here current leads voltage by how much? 30 degrees. I mean, this technical I can expand as current leads voltage lags by 30 degrees. This is how to understand the beauty of phasor diagram, is how to understand how current leads the voltage and lags by 30 degrees. This is how to understand an inductor lags voltage and leads by 30 degrees in the case of an inductor and capacitor. Hope you have understood the phase difference well. Okay, so very simple, and current will have minus 30 degrees and capacitor will have plus 30. If you understand these waveforms, you can. So at the top we are going to have capacitor, at the center we are going to have resistor, at the bottom we are going to have inductor. If you understand these three, the things are very simple. Okay, so this is how to draw the phasor diagram and phase difference. So hope if you understand my explanation, share the video with your friends and like the video. And if you're watching, if you have any doubts at any point, just comment me in the, I can answer your doubt. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. Thank you for watching the channel. Yours Ram.